Hello, this is Susan Poss with Spartanburg Community College. This is Chapter 4, which is all about graphing. And this is Section 1, and this is the first video. So you see it numbered 4.1.1. We're talking about a rectangular coordinate system. You'll sometimes hear me call it a grid. It's also called the Cartesian coordinate system because it was first introduced, we believe, by a man named René Descartes, who was a Frenchman. And you've probably seen a grid like this before, a rectangular coordinate system. And I wanted to just identify some of the important components. The horizontal number line is called the x-axis. And you see it has positive numbers on the right of 0 and negative numbers on the left of 0. The vertical axis is called the y-axis. The positive numbers are above 0, moving upward, and the negative numbers are below 0, moving downward. This pair of axes divides the two-dimensional space into 4 quadrants. Quadrant 1 is in the upper right. That's where all the points are located that have both a positive first component and a positive second component. Then you move counterclockwise. Quadrant 2 is upper left. It has a pattern of moving left first, followed by moving up second. So all the points in quadrant 2 have that sign pattern. Quadrant 3 is down here in the lower left. All the signs in Quadrant 3 start negative to the left and down, negative. And Quadrant 4 is the lower right, and the sign pattern there is move to the right first and then down. It's important, if you're going further in mathematics, that you understand those sign patterns. All right, so I thought, there's one more thing I wanted to label for you. This center point here, which of course we'll talk about coordinates in a minute, has coordinates 0, 0. You will hear me refer to this as the origin. So that's where we will begin all of our plotting. So I've got some points listed over here. These points are called ordered pairs. The first coordinate is the x coordinate, and it gives you motion on the x-axis. The second coordinate is the y coordinate, and it tells you the motion on the y-axis. So the first point you see listed up there, point A, has coordinates 3, 2. That means we begin at the origin. We count 3 units to the right. We turn at a 90-degree angle and move up. And the point A, which has coordinates 3, 2, is located there in quadrant 1. Positive, positive. That doesn't look much like a 3. Let me go back and make that look a little bit more like a 3. All right, point B has coordinates -7, 5. So that x number is first. I will move in a negative direction, 7 units to the left, turn at a 90-degree angle, and move 5 units up. And here is the point -7, 5, which we're calling point B. It is in quadrant 2. The third point, point C, has coordinates -3, so I'll begin at the origin and go 3 to the left. -7, so I'll turn that 90-degree angle and go down 7. And here is the point C, which is -3, -7. And you can see that negative pattern in the sign. The fourth point D has coordinates 4, -3. So I will go 4 to the right, turn and go down 3. And there is the point D, which has coordinates 4, -3. And you can see that sign pattern there, positive first and negative second. Now I did want to show you a couple that are going to be on an axis. So point E has coordinates 0, 5. So remember, we start at the origin. If the first number is 0, we do not move up, we do not move down. We stay right there on the origin. And then the second number is 5. so we move up 5. So here is point E, which has coordinates 0, negative 5. And I think I'm going to change this next one, point F. Let me change the coordinates here on point F. I'm going to make it negative 5, 0. Okay, so that tells me that the x motion on the x-axis tells me I go back negative 5 to the left, and then the 0 coordinate here for y says do not move up, do not move down. So I'm going to stay right here on the x-axis, and there is the location of point F. So I hope all of this is a quick review for you, hoping that you've seen this before. I did a rough sketch, and it's very rough, but I did want you to note that a rectangular coordinate system is not the only way to graph. There are multiple forms for graphing. One that you might be familiar with is called the polar coordinate system. It looks like a radar screen, and you identify points there by looking at the distance from the center and then how many degrees of rotation that line, that vector has passed through. So we're not going to be doing that in this class. If you continue with math, you will definitely be doing some of those polar coordinate systems. I'm just going to plot a couple of these points. I'm going to do the first, let's do the first, the third, and the fifth. So the first point A, coordinates 5, 3. Here's the origin. So I go 1, 2, 3, 4, 5, turn and go up 1, 2, 3. Then I'll do negative 2, negative 4, so I go back 2, down 4. There's the second point. It is called point C. And then 0, 2 says start at the origin, do not go left, do not go right, go up 2. So here's the point 0, 2, which we are labeling point E. All right, so you can practice the rest of those if you want to. The next thing I wanted to show you is let's go ahead and talk about an equation that contains two variables. One is the variable x, the other is the variable y, and of course those are going to coordinate with the x, y coordinates in a point. So over here on the left we have, I'm going to label it, we have a point 0, 12, and I want you to associate the 0 with the x and the 12 with the y. And what we're supposed to do here is determine if this ordered pair is a solution for the equation. And the way you do that is you substitute in the numbers. All right, so here's the equation. Let me just write it down. And we're replacing x with 0, and we are replacing y with 12, and we are asking ourselves the question, is the left side now equal to the right side? If it is, we'll say yes, this point is a solution. If it is not, we'll say no, this point is not a solution. So then you just do the arithmetic. 3 times 0 is 0. Subtract 12. I'm going to have negative 12 on the left. That is not equal to positive 12 on the right. So we'll say no. This point is not a solution for 3x minus y equals 12. Okay, so we'll try one more. We're doing the same thing. We're trying to decide if this point is a solution. So we'll take the equation and we'll replace x with 1 and we'll replace y with negative 9. And then we're asking ourselves at that point, is this a true statement? Is the left side equal to the right side? So then you just do the arithmetic after you've done the substitutions. This becomes positive 9 plus positive 9. We're still asking ourselves if that's true, and you can see that this turns out to be true, so we will say yes. The point 1, negative 9 is a solution for 3x minus y equals 12. And I just left these others worked down here. I thought you might want to just take a look at those. Maybe you could freeze the screen and look at those. All I did was take the equation that was given to me here, x plus 3y equals 6, and they gave me 3 points to test out. I tested all 3 points. I got a yes on the first 2, that they are points on the line, that they are solutions to that equation, and I got a no on the last one. And you can see the points fell into the same line that were actually solutions. And the one point that was not a solution, I have it highlighted there in red, and it's clearly not on the line. So I'm going to stop there, and we'll pick up again in a minute.